Alright guys, let's do one concept map for Arenes as well. So we start off obviously with benzene ring. Then using concentrated nitric acid and sulfuric acid 55 degrees, we'll get nitration. Adding a two group. This is electrophilic substance here. But with the Lewis acid catalyst, I'm just going to add a halogen, in this case chlorine, directly to the benzene ring. Okay, now with the Lewis acid, right, my reagent is CH3Cl. This is also electrophilic substitution. The ring, but this time round, the electrophile is your CH3 plus, right? So I'm gonna add a methyl group to the benzene ring. Okay, so we do repeat some of the same reaction. So concentrated nitric and sulfuric acid this time around at 30 degrees because the ring is slightly activated by the electron donating methyl group. Okay, so as it is like 2,4 directing, so I can put my nitro group to the 4th position. Then if I use hot acidified CmO4, I am going to get a benzoic acid because this is a side chain oxidation. Up, then up. Time round, it is 2,4 substitution. You can have the methyl group either on the second, the 4th position. Okay, so limited chlorine with UV light. This is your free radical substitution. Then on the side chain, last but not least, electrophilic substitution again. Methyl group is 2,4 directing, so put the chlorine on the 4th position or the second. Okay, so that's how we do your set map for Arenes. Okay, so let's continue. So this time round, I'm given the products. I'm required to put down the reagent. Okay, so nitration is just corn nitric acid. Acid. Since it's a benzene ring, it's 55 degrees. This one you need a Lewis catalyst, and the reagent itself can be done at RTP. Okay, so this reaction, I'm going to use the Lewis acid still, but we need a different reagent, H3Cl, so that the methyl group can be the electrophile. Again, it's still at RTP. Okay, so now to do nitration, right, on methyl benzene, which is slightly activated, I am going to use nitric acid concentrated, sulfuric acid concentrated, but at 30 degrees. A reduced temperature because it is activated is directed to the 4th position. Okay, because of the 2,4 directing methyl group. Okay, so methyl group is always going to direct to 2 and 4 position. Please take note. Okay, so this is your strong oxidation. NO4, uric acid aqueous, heat, side chain oxidation. Then you have a electrophilic sub of methyl group. So just take this and feed it here. Okay, no change in the reagent and condition. Okay, for side chain free radical sub, we're going to use UV light. The green. Right. Last but not least, have electrophilic sub of chlorine. Okay, electrophilic sub of chlorine, we can use this particular agent condition. Just bring it down here. Same. Right, so that's it for all the reactions with arenes.